Canada did not have an international caliber 250-meter track velodrome. There was one in 1976. It was torn down, I believe, in the late 80s. So in order to train on a 250-meter track, oval, you'd have to go down to LA or somewhere in Europe. So, that puts you in a disadvantage. So if you're training on a 200-meter track, which we do have a few of them in Canada, it's kind of like competing in T-ball and then going and trying to play in the majors. That's essentially what our athletes have had to do. Now, to talk about the venue and its impact on Milton, I think it might still be the fastest growing municipality in Canada. Please welcome David Kirkland, Chief Operating Officer and Executive Vice President at Kenaidan Contracting Limited. And if you did notice a little bit of an extra bounce in his step, it's because his Black Caps are off to the Cricket World Cup final. New Zealand, first time ever making it this weekend in Melbourne, right?
Yep.
Okay.
Thanks, Signa.
Yep, okay.
So Signa did catch a little bit of my thunder there. And just listening to Douglas, actually, Douglas had such a good presentation, I almost forgot that I had to do a presentation as well. So I'll try and get myself back into a routine here. Douglas mentioned he's an architect, and that's okay. An architect in front of a group of engineers, that's fine. I'm a contractor. You think that's even worse. And I'm an engineer as well, but I'm standing in front of a group of engineers and thinking, holy crap, there's nothing more intimidating than that. So I'm going to talk about the Milton Velodrome. I'll talk a little bit about the P3 process. Douglas gave you a bit of information, obviously, about it. We were part of a consortium, so we were at the Project Co level. As you look at all those arrows that are coming down to the bottom, that's basically where we ended up. So we were one of 3 proponents submitting for this particular facility and a couple of others as well. But there's pros and cons to the P3 process, but certainly in this case, the emphasis on the schedule and guaranteed costs, I think, was very important for the province. And facilities such as what have been built for the Pan Am Games and Olympic facilities historically certainly can be subject to certainly schedule and cost overruns. So I think the entire community around the Greater Toronto Area and Southern Ontario should be very proud of the fact that the facilities are, in fact, all going to be ready in time for the Games. The Velodrome is actually, again, Signa, you mentioned Rick Mercer was there a few weeks ago. I don't know whether you guys saw the clip on Rick Mercer. It was one of my favorite shows, and he's a game guy because when I first got introduced to this concept of track cycling, and I'm a road cyclist, I enjoy road cycling, I looked at track cycles and I thought, there's something wrong with this. You've got no brake. In fact, you've got no gears, and you can't freewheel, so how the hell do you ride these things? Anyway, so I got introduced to it at the track, and I realized at first, at my age, there was no way I'm getting on one of these bikes. I'll stick to the road, thank you very much. So when I saw Rick Mercer actually riding around, I think with Steve Bauer on the track, I thought, man, you are one heck of a guy for doing that. And he seemed to survive without actually having any accidents. But for those of you who don't know, the bikes are truly, they're an invention where they're one gear, direct drive, there's no brake, and so if you want to stop, which sometimes you do want to stop, you actually have to keep pedaling and use the track itself as a means of slowing down to a point where you can safely dismount from the bike. And at that point, I would have said, it's not for me. Anyway, I think for Cycling Canada, certainly it's a great facility because, as Signa mentioned, there's only one other facility similar to that in North America, and that's in the Los Angeles area. And so it's very exciting for this community because, this is now their headquarters for Cycling Canada. They have a facility which they truly can use for international training and international events. And even for, it's interesting as a legacy event or a legacy location, I know a lot of cyclists in the Toronto area are actually really keen to try out the facility because as general public, you can ride this track, you go in there, you pay a fee, you can join a club or you can go and pay a fee, you go through a bit of a training exercise, you can rent the bike, and you can knock yourself out. And but it's really good for encouraging a different type of sport because track cycling is totally different than road cycling, that's for sure. And again, not having really known a lot about track cycling before we started building this facility, but having watched a bit of it since then, I think it actually is going to be one of the sports in the Pan Am Games, which is actually pretty exciting. You do need to understand not the techniques, but the strategy behind the riding, but it's a very entertaining sport to actually watch because of that. Anyway, enough on, I guess, the type of event itself, and I'm just going to talk a little bit about the build side of this facility and try and introduce some of the technologies that contractors, ourselves and other contractors, typically employ widely in construction projects now, and nothing's unique. You guys are engineers or architects, you know, CAD, laser point scanning, that sort of technology, Revit, you know, it's very common in the industry, but as contractors, you know, we may be a little slow at times, but eventually we look at technologies and we go, oh yeah, I think we could actually probably use that. And then what we do is we take it, and I'm proud of the fact that as contractors, we take it and we advance it a bit further. So we use technology these days really to help us manage and develop construction schedules, manage and deal with conflicts, coordination of drawings, a whole myriad of issues that, you know, we've grasped on the different technologies that you guys would use, you know, those of you in the design community certainly would use for the design process. So anyway, just a little bit about, if I can work this, I'll keep talking, but that's the facility itself. As you say, it was fairly cold a few weeks ago, but the facility is up and running now. Part of the P3, if I get back to the P3, is as a proponent, we have to sell our proposal. It's not just cost-driven, it's also technical. It's based on our proposal as a complete package, so it's part cost, part technical, and part past experience. So one of the things we had to do, we were part of the consortium, we were just a minority partner in the consortium, but part of the sell part of the job was to really demonstrate to Infrastructure Ontario what sort of a product they would be getting at the end of it. So if I can run this video, it just gives you a bit of an indication of, I got it. This is the type of cell that we did beforehand. So this is concept more at the time of putting the original proposal together. And it's interesting to later on see, in fact, that not a lot changed through the design, development, and the construction process. The intent of this facility is again to maintain a legacy mode, and clearly when you think of a velodrome, you know, you think, well, what else can it be used for? And it is difficult to create a legacy mode that the town of Milton, in this case, can use, which goes beyond the cycling scope. So as later on you'll see, part of this process is to create an infield, to create a facility which can be used for a public gymnasium, for basketball events, volleyball, badminton. There's an interior running track, and just generally community access and use as well. So it was a very important part of all of the Pan Am facilities, as Douglas mentioned, to try and create a good, strong legacy use. Anyway, I'll run through this video, but it's part of it. I just wanted to show you too is that for the legacy, we had to create access to the interior of the track, and obviously you're not going to clamber over a cycling track to get to the basketball courts or the badminton courts. So all of the access is through central corridors and tunnels underneath the facility, leading out to the central area. So the track is around the perimeter, but the area in the middle there is the legacy use where we've created basketball courts, badminton, volleyball, and potential for using for a movie theatre. I'm not sure whether they're going to or not, but it could be BMX. We had this vision that maybe they could actually use it for BMX bike events as well. But again, going to the theme of making sure that the town of Milton, in this case, has a venue which is truly a legacy venue that they will be able to use for multiple sports in the future. The location of the velodrome actually is on the west side of Milton, and I don't know whether you know Milton very well, but as Signe said, I believe it is the fastest growing community in Canada, and development is coming all around this area, but the velodrome at the moment is still out in fields, I guess open fields, and it's got a really cool backdrop to the Niagara Escarpment as well. Eventually, I believe the town intends to use this more as an educational centre, so the likes of L'Oreal University is planning a small campus there, and other facilities which go more to the educational approach. Anyway, I'll try and stop this thing now. So just moving on, we mentioned before the cycling community is really excited about this. Well, Kurt Harnett, most of you remember him as being an Olympic medalist. Kurt and Steve Bauer were the first to actually use this facility while we were still constructing it. We had the track completed, the rest of the building was still in construction. They came in their hard hats, and then we allowed them to actually run their bikes around the track, not in their hard hats, but in their cycling helmets, because we felt they'd be pretty safe. But they were really excited about the fact that this facility is now available within Canada. I think the difference between Kurt and Steve is that Kurt has hair, Steve has nothing. Just some of the sponsors involved. You see the 2015 Town of Milton and Infrastructure Ontario, and others involved in the design and the construction of the facility. I have to give out some credits. So just a few things about the construction itself. You saw in Douglas's presentation some of the long spans over the Aquatic Centre. Similar to the Aquatic Centre, the Velodrome has to have clean sight lines, has to have sight lines for broadcast as well. And so we had to design and construct clear span structural steel was the preferred, obviously the preferred mechanism, but these trusses varied in length because it's an oval type facility, but the maximum length I think was just under 90 metres, so it was a very broad span truss. The trusses are about 5 metres deep. They were actually fabricated in 3 sections and then bolted together on site, lifted in one lift with a couple of 100-ton crawlers. And when the process of erecting the structural steel was underway, pretty much everything within the confines of the Velodrome area for construction had to be put on hold. So the structural steel obviously took precedence over every other construction activity within the envelope of the Velodrome. Again, just a cross-section. You see if you're looking at the occupied spaces on the east side is the mechanical electrical areas. And what was interesting about the mechanical systems was everything was located within the building. Nothing, apart from a couple of condensing units, nothing was actually outside. Everything was within. And similar to the other events, the air movement and air control is an essential part of a facility such as this. So in the case of the Velodrome, I think the temperature range has to be very close to 24 degrees Celsius, and a humidity control of about 35% humidity levels as well, because you've got a wooden track within the facility and you have wooden gymnasium floors as well. So temperature control, volume change, everything is very critical. And then on the west side, we had the balance of the services, gymnasium, offices, and then the broadcast level up here, and room for legacy seating, not legacy seating, additional seating for the games themselves at the upper levels. The legacy is about 1,500 spectators. For the games, I think we add an extra 1,000 seating capacity for the actual games themselves. And then the other thing, in the middle of the Velodrome itself, the track is at this level, and again, Douglas was talking about entry level at different levels. So for the people attending the games, they'll come in at level 3, looking down onto the track. The cyclists and all the athletes will be down at the lower level, separated from the public at all. So the access is up to the Velodrome level at this level here, and then all this area, and this is actually compacted engineered fill. So we couldn't create a void space under the central area of the stadium, of the basketball flooring. It had to be compacted fill, and all of that had to be done after the structure was up. Another use we have for ourselves as a contractors is the building information modelling, and clearly we take documents which are given to us by the consulting industry, hopefully in an electronic format. We can create them in electronic format if we have to, but this job in particular was done on Revit, so it was already done as a 3D model. We then take that information to help us with preparing logistic diagrams, with preparing sequence of construction, with looking for clash detection particularly with the mechanical, electrical, and plumbing systems. And I'm just going to run you a short video which will, if it runs, I'll just show you the outline of what we put together in terms of the model. Now this is just a video, but the video has different components of the model that we use for different aspects of the work. So we start with a clean site. All of the foundations are founded on unshrinkable fill. We started with the concrete structure, retaining walls on the east side, strip footings. Everything is strip footings and pad footings. Concrete work and structural steel starts to be erected. trusses dropped on. Everything looks so easy, I know, but it's not quite that easy. And being a contractor, we don't quite do it in the sequence that we say we're going to do it either. So it didn't necessarily go in exactly the same sequence, but I think you get the picture. But for us, it's very important because we can dimensionalize everything. We can take those drawings and we can prepare shop drawings. The structural steel shop drawings were all prepared from the Revit models. Very critical because of the dimensioning on the structure itself. The girts around the perimeter were all radiused. They weren't just straight sections, so with the radius sections we had to determine through the model. On the inside, then once the structure was up, then we started work on the infield. So we had the concrete work on the infield. We had the backfilling, as I say, to bring the infield up to grade level. The track itself is built on structural steel beams, steel decking, and concrete decks, so everything is elevated at that section, but the infield is all in grade. You can see the access tunnels, one at either end for the athletes to get out into the center field. And it's kind of, say, we use different components of the model for different reasons on the construction. Sometimes sequencing, sometimes for coordination of different trades. But pretty much everything on this job was modeled. In fact, not pretty much everything on the job was modeled. You see the track slab going in, and then we start looking at the bleachers, the structure, and all this work was completed after the main structure was installed. You know, the roof is not shown as being on at the moment, but because you see that nice shadow moving across, that's the roof. In actual fact, the roof was enclosed well before the interior structure was completed. On the outside, we had extra retaining walls because we had to build the east side of the facility up to the level 3 entranceway. Remember to keep the public away from the athletes, so everyone's entering from this area here. So we had to build additional retaining walls because of the additional surcharge on the main building retaining. And so everything comes up. And so that was the structure. So we had a pretty good understanding now what the structure would look like. Then we had to turn our attention to the MEP systems. Again, there's a lot of air in this building, a lot of ventilation systems. So with our subcontractors, we had to model all of the mechanical, electrical, sprinkler systems to ensure that we minimize clash detection. Now, I would like to say we didn't have any clash, but that's pretty unrealistic. So we had a little bit of clash. I'd like to say probably 90% of it we avoided. But this is sort of an example of what most contractors are doing now, utilizing the technology that the consulting community are already utilizing, but we're using it for our own purposes to really maximize our efficiency in construction, to minimize rework, and also to assist the consulting community well in terms of coordination of drawings and different facility, different fixtures. So you see the mechanical systems are going in. Again, not necessarily in this sequence, but we know they're all there. And then we turned our attention to the partitioning within the building. Now, the partitioning, I shouldn't say we turned our attention to it at that point. We included the partitioning because, again, it's part of our clash detection with services, and sometimes different building components, different fabrics clash in the drawing. So you want to make sure you've got a drywall where it's supposed to be drywall and not block wall, silly little things like that. And the exterior cladding system, which Douglas already mentioned. Oops, I'll skip over the rest of it. You know, so I think you get the picture. Basically, the building structure and the fabric were all modeled so that we could really, as a contractor and working with our designers as well, deal with issues before they became construction issues as much as possible. Just a few shots of the actual completed or through the building construction process. The acoustics are very important in this building, as indeed they are in the aquatic facilities as well. Nothing magical about how we approached it. The ceiling, the acoustical ceiling is basically a steel pan, acoustical steel pan. There's acoustic panels mounted on the walls all around. All suspended slabs had acoustical treatment, whether it be a sprayed treatment or whether it be a double drywall treatment, all with the intent of keeping the sound, the STC ratings down between 45 and 65 dBA, depending on where you are in the facility. But it's interesting, if you do have the opportunity to go into the facility, you'll find it's a very hushed environment, so that you can quite easily hear someone quietly talking on the other side, and it's kind of an eerie feeling almost. If there's nobody in the building, it's very eerie. But the intent is to keep the sound noise down so you're really not distracting the athletes on the track. Construction, a few photos of construction. We started in April of 2013 after, it's the best time to be starting because the ground's nice and wet and soft. You know, there's usually a bit of rain as well, but hey, we're contractors. We're not that smart sometimes. Everything was founded on, the soils itself were marginal for bearing capacity, so everything was excavated, unshrinkable fill places, the subgrade, and then everything was built up off of that. You can see on the left side, we're starting to build up the platform outside of the building as well. Reinforcing steel, pretty interesting, eh? Lots of it, I can tell you that. About 800 tonne of it, I think. Structural steel, I think it's about 1,800 tonne of structural steel. The trusses, as I say, they were big. You know, the photo probably doesn't do it justice, but certainly the installation process was a pretty neat affair to watch. Once they got it down pat, erecting a truss every 2 to 3 days, so it was a pretty good process. And then once the building structure was up on the outside, the roof was on, and we started with the exterior cladding, we were able then to recommence all the work inside the arena itself. And it was a very congested site, so we had mechanical, electrical systems being installed in the ceilings, we had fill coming in to bring it up to grade, we had concrete walls being constructed, we had suspended deck, so ready for the track, and at the same time we were trying to close the building in, all to a pretty aggressive schedule. And I wouldn't say that everything was seamless in there. It was, you know, we're contractors, there was a certain number of arguments, but, you know, by and large, everyone did tend to work together. A plan had to be logical, but it also had to be flexible. And closer to the end, you see we're pouring the slab on grade for the infield, and we're bringing in we brought in the timber now for the actual track itself. And I'll talk about the track. Actually, I'll talk about it right now. Track itself is probably the most interesting part of the facility. The wood itself is Siberian spruce, and it was harvested, I think, late in the year 2012. So that was one of the first things we had to do, was actually order the wood. Just as soon as we got the contract, we were on to the supplier for the wood, because it had to be harvested, cured over a period of time, and then pre-cut and pre-assembled in certain sections so that they had adequate time so they'd be ready for our construction schedule. And then the installation, I believe, started in June of 2014. So you see there's a long time period in there. The installers, they're pretty unique, I got to say. They're German. Okay, I don't know if there's anyone German in the room, but they're very black and white. And there's only 3 companies in the world that we're aware of actually are able to install a velodrome to the tolerances required for the UCI rating. This company, Velotrack, I think, they were very, very efficient in what they did, but they were very old school as well. You notice the lead guy here, he's using a handsaw. He didn't believe in electric saws. So fortunately, most of the wood was all pre-cut, but every time he had to do any modifications, it was a handsaw. They also didn't believe in what we Canadians call personal protective equipment. So they wanted to wear their running shoes, shorts, and T-shirts. So we had some challenges. We had to convince them that, well, okay, at least when you get into the building, you have to wear your personal protective equipment. But we had an arrangement whereby once they're inside their working track with the Ministry of Labour, we agreed that they could hang their hard hats on a board with their name on it. They could hang their vests on a board, and they could take off their safety boots so they could put their running shoes on, and they could work within their confined area. But they were not going to work with PPE. It was just not part of their mentality. So anyway, we got along pretty well after we sorted that one out. But it was the structure itself was quite interesting. It's all wood. It's sitting on the concrete slab, but there's a subframing of, I think, 2x6s, 2x8s, all pre-cut. And the subframing goes in. It has to go into very tight tolerances, obviously, because it has to meet the UCI rating. And this is another use that we found with the CAD modeling. We could make sure our structure was in fact going to be such that the track substructure would fit within the structure within the tolerances required. So once the substructure was down, then they started putting every single board in place. And the boards were typically 30 millimeters by 30 millimeters, individual boards and individually nailed. I think there's somebody told me there was about 1 ton of nails used in the facility putting it down. But it is a very methodical, steady process. But they're very precise and very efficient. And in fact, the whole track installation from start to finish just took 8 weeks, which, quite frankly, we weren't sure that that would be the case. We thought they were going to need a lot more time. So that was the track through the construction. Really interesting to watch, I must admit. And then we had the first test event. Actually, I think this is an event that was held in early January, but there was a lot of trials and tests before that. Interesting thing about this is called the pace bike, I think, or the pursuit bike, pace bike. It's actually an electric bike, but it's got the power of a 250 Yamaha. Like, it's a pretty good bike. And to get the certification on the track, this bike had to reach 85 kilometers an hour going around the track, and prove that the track, in fact, was safe. And you know, I'm watching this bike and I'm looking at the track and thinking, 85 kilometers an hour, like, you know, is it like motocross or the Indy 500? This is crazy. The guy was just spinning around the track. So again, there's not many riders actually available. In fact, I think the guy that actually was the lead foreman for the track installation was also the pace bike rider for the certification. So he was a multi-headed chap, German, like I said. It was about this stage I decided that I probably wasn't going to try one of these bikes out. But you can see the facility. On the corners, I think the gradient is exactly 42.5 degrees. So there's no climbing up the track. And certainly if you want to come down, you're going to fall down in a hurry. The only place you're going to move across the track is at these locations there, if you must. The track surface itself is just plain board. There's no varathane or anything on it. It's just a sanded finish. I think over time, you know, they can mop the finish. If you go into the facility now, you'll see that the lower levels, where most of the bike traffic is, you'll see there's quite a blackish mark on the track. So, you know, the wheels stain up the track, and I think all they do is they just mop it down after each event. One other technology we use, and we use this as a contractor quite extensively now, and that's the 3D laser scanning. For us, we scan this facility at the construction process. You can see the structural steel is in place. A couple of reasons. We continue to learn more about the technology, and we find as a contractor we've got some pretty cool uses for it. But in this case here, it was also very good to determine where we may have tolerance issues, and yes, we did have some tolerance issues, to give us accurate as-built information of the structural components. It was particularly helpful when we were installing the girts and determining the sizes required for the insulated panel on the exterior. So there was a number of different uses that we found for it. We do this ourselves. I think two of our BIMsters, or two of our field engineers, spent a couple of days on site with the scanner. I think they probably used 15 to 20 setup points around the job to give a complete picture of the structure, and then another 2 or 3 days to input all that information into the Revit model. I'll just give you a quick rundown through it, but it's probably not that exciting. But again, we're learning more about this technology. We've used it quite extensively now for surveying existing buildings when you're doing demolition and retrofit, because it'll give you a very accurate representation of what's in the existing building. We use it for shoring projects, excavation and shoring, so that if we have a shoring system, we want to determine exactly the coordinates of the shoring, so we know exactly whether we have any interferences from shoring into the excavation, how much concrete we may need to pour if we're pouring concrete up against shoring. So we're finding a multitude of uses, and the more we practice and play with it, the more we'll find that we can use this technology. Obviously, it's very coarse when you look at it like this, but the information is all embedded in the model, and it picks up everything that moves. I mean, you've got excavators there, you've got people there, so whatever's standing in the way at the time of doing the scan, it'll pick you up. That's not to say that we're going to put you into our model at the end of the day, but it's very useful for when we're doing the as-built structural information. I won't bore you anymore with the technology, but just finally, it is, as Douglas alluded to, all the facilities, I believe, are LEED or designated for LEED Silver, so nothing particularly special about it. The usual things about stormwater management and control. this building, it's a uni-slope roof, which is not a lead requirement, but it's a structural, well, it's an interesting way of controlling the drainage, but it's a TPO membrane on the roof, so it's a heat island, I believe. The hard surfaces around the facility itself are stained asphalt, stained concrete, so that we get more of the heat island effect as well. Usual things inside, the LED, complex fluorescent fixtures, low VOC components, you know, all the normal stuff you'd see in a lead facility. And then just finally, oh, by the way, if you haven't seen the Rick Mercer clip, you should see it. It's on cbc.ca, and it's really entertaining. So I was very impressed with Rick Mercer, actually getting a bike and riding around this facility. Interestingly enough, when the athletes are actually riding, the woman will ride up to about 64, 65 kilometers an hour. This is the woman, and the men will get to 68, 69 kilometers an hour. So if you can visualize that around a 250-meter track, that's really flying. You know, it's pretty scary stuff. So I'm not going to show this now because we're probably going to run out of time, but this is just a video. If you wanted to see it on YouTube, it was one of the first rides that I believe Steve Bauer did on the track, and he's just got the GoPro head cam, and it's kind of interesting to see how they actually get themselves in a position, how they get higher on the banks, and how they get back down lower again. And for the first lap, probably, he's wobbling. Like it's difficult to get up to speed because you've got no gears. You've got one direct drive, and it's a slow, tedious process to get up to speed. So it's kind of interesting to watch that if you are at all interested. And that, I believe, is all that I have. Thank you.
What is the button?
That's underneath.